roughly like 20 to 25 questions, roughly. The final is going to be about 30 questions. We do have a little more time than normal, so our class runs for an hour and 15 minutes, right? So on the final we have 2 hours. So I can make it a little bit longer than normal, but not a lot. So you take a normal test and you add about 5 or 6 questions on top of that, meaning ABC, not 5 more questions each with ABCs or equal that. So roughly like 30-something problems on there. Yeah.
Could you give a sample of what kind of questions you would ask about histogram?
I would give you a histogram that's been created, and actually there was one of these problems in that section, and they ask you questions like, what's the modal class limits? What's the class width? Those kind of, so if I see this, what is the class width? 5. What is the modal class limits? What is the modal class? Which bar is the modal? Mode means what?
The most common.
Most. So which one has the most in it?
2025.
Yeah, 2025. Let me catch up to you. Sorry. So I heard you. It's all right. You know, stuff like that. Nothing major, right? Because to be honest, one of the SLOs we had to check last semester, which we're probably going to do again this semester, is just how to read a histogram. Right? It's one. I don't know if you guys know what an SLO is. It's a student learning outcome. Yeah. Over in Virginia, they were appropriately called SOLs, which I thought was funny. But pretty much summed up how I felt about them. But yeah.
But that question you're gonna ask about Boylan
I could ask you the midpoint of one of the classes, sure. The midpoint is just where you take the average of the two. Yeah, not a big deal. Okay, so let's take a quick minute here and talk about the formula sheet. So I've already said, 1 was definitions anyway, but that's not going to be really on the test. 2 is histogram stuff. I'm not going to make you create your own histogram. 3 was calculating mean, median, mode, mid-range, that kind of stuff. It is possible I'll have a question about mode, like I just did, a type of question. It's possible I have a question about median, so you're going to want to know how to calculate that. So if you want to, you could put down, I don't know if you remember this, if anybody used this formula for the median. You guys remember that? Because the idea with the median was it was the number in the middle. But when you have 4 numbers, what's the number in the middle? The number in the middle of the 2 in the middle. Yeah, that's the number that's right in the middle, exactly. But those are more ideas, less formulas anyway. You should be able to find the median of a set of numbers. You shouldn't really need a formula to go to. But you can put that down if you want to. Chapter 3 introduced z-score. So obviously z-score is kind of important. And I don't know if you guys agree with me or not. It's true, the z-score formula never changes, ever. It never changes, ever. It's always our stuff minus the middle divided by the standard deviation. Always. Even in Chapter 9, if you've looked at Chapter 9. There's just 2 of everything because I have 2 samples, but it's still the same stupid formula. Never changes. Chapter 4. That's going to be on the final.
So we have a formula for x, like mean plus...
Oh, x bar? No. Oh, sure. Yeah, you can turn this bad boy around. Cool. Now probabilities. Who remembers the probability of A or B? What was that?
Probability of A plus probability of B?
Yeah, or basically meant add, but you had to subtract off any that were twice, meaning any that were both, right? If something's both A and B, it would get counted in both A and B. I better subtract one of them off so I don't double count it. What about A given B? What was the formula there?
Subtract.
Probability of A over B.
This isn't just a straight up division symbol here, right? A given B. So it's given B, so that's got to go on the bottom, right? So if it said given men and there were 40 men, then it's going to be out of 40 people. So that kind of makes sense. So given goes on the bottom. On the top goes everything that's B that's also in A. That's the only way you can be B.
Probably A minus B?
A
No.
and B.
Yeah, A and B. Yeah. Cool. So yeah, I like the looks of some of your faces. You might want to go back and do that. And that actually led to the formula for probability of A and B. Let me just write it like this. Just solve that for and again, each of these formulas, you most of the time don't need them, right? If I give you a chart problem, you just count. You don't need the formula, you just count and make the ratio. Not a big deal. This kind of problem was like a king and then an ace. So you do the king times ace given king, and the second one might change if it's without replacement, right? Remember that stuff? Throw the card away, I didn't replace it, so it's going to change the second probability. Oh shit. Go back and redo. I think that's it for probability.
This is all chapter 3?
This is 4.
Oh, that's
Yeah.
4, right.
Okay, so what about chapter 5? That's where we get into the x, p of x stuff, right?
Are you gonna have us take a document from 3
To do what? Sorry. Oh, box and whisker. Whoa. Okay, I didn't get this turn. If I could. Looks like I'm not going to. Oh, poor little dude. Okay, that's excessively freaky. All right. Yeah. What the hell? Me am smart. So chapter 5 is where we did stuff where I give you like x, p of x, the tables. So what's the formula for the mean in that case when you have x and p of x?
Sum of all x.
Yeah, to multiply across and add down. Remember that stuff? So that's chapter 5. So the sum of x, p of x. What's another name for the mean?
Average.
True. But one that we were introduced to in chapter 5, EXP is actually the first 3 letters.
Expected value.
Expected value. Cool. So the mean is also called expected value. So if I ask you a question where I say, what's the expected value for this? You know that I'm asking you for the average, the mean. Standard deviation in this case was a slightly freaky thing there, right? Let me see. Chapter 5, the next level was binomial probabilities, right? And that's where we have this. No. It's all right. I'll do it. So that's the probability for when you have a binomial distribution. What's binomial refer to?
2 outcomes.
2 outcomes, right? So that'd be like rolling a dice. You'd think it's 6, but if I said I'm looking for 5s, I'm playing a Yahtzee and I have my 5s are free. I want to probably get some 5s. It'll be a 5 or not a 5. So there are 2 outcomes there. So P is probability of
X occurring.
in general, P is a probability of success, and Q is probability of failure. Cool. I like it. And then the mean and the standard deviation for binomial kicked ass. And in fact, we've seen this come back recently. What was the mean for a binomial situation?
NP.
NP. Careful. So NP is the mean, and we've seen that come back, haven't we, recently? That's what we check. NP and NQ is our check to see if something's normal or not. So the mean is NP. Standard deviation was NPQ. I like it. Cool.
What did you say that standard deviation on the top is for the EX?
This is for chapter 5.
Okay.
And it's really interesting. I want you guys to notice. Sometimes the formulas we use are notes themselves. Remember this guy? This guy is actually the definition of z-score, which is really funny. What does a z-score tell you? How many of these go away from the mean to get to a data point, right? How many standard deviations away from the mean to the data point? That's kind of crazy. So I don't allow you to have notes, but the formula is a note. So what can I do about that? So the better you get readings in English, the more notes you have than you think. This one, the other kind of formula that's nice is, when do I use these? Well, when I give you x and p of x. Right? It's that simple. I can't use this shit when I give you x and p of x. I can't use it here. I got to use this when I have x and p of x. So that's pretty much of a giveaway, right? I use this when I have an NPQ problem. I have, 80% of people like to do this. If you pick 20 people, well, there's n, there's p, q would be 20%. Okay, it must be an NPQ problem. Must be one of these two, right here. Cool. Yeah.
You're still saying no words on our formula sheet?
Definitely.
Can we break them
No.
down by chapter then? I.e. Roman numerals or circle digits?
All right. You
Circle
could
square
put
star.
chapter 4, chapter 5 is fine. Yeah.
And I can write the word chapter.
You can't.
Just
I'll allow-
checking. I don't
I'll
want to
allow that
word.
You don't have to come up with your own shorthand for chapter. But I don't want to see any of this in the corner. I love that. What's that? Can you guys see that? 68, 95. I saw, and I love it when I see erasures, and then I can just kind of, oh, that's what used to be there. Most interesting. So, just be careful. You don't want to lose points in your formula sheet. That's just silly. So this is chapter 5. All of this here is chapter 5. Chapter 6 was where we really used the hell out of z-scores. Right? So we have the old z-score formula. So I don't know if you want to put it again. Yay. You got this one too. I don't know if you necessarily have to write both. You really don't. They're both the same thing. They're both data point minus mean divided by standard deviation. You can write this one here. What was that one? The new standard deviation is?
Standard
Sample
deviation over
deviation.
That's right. And when do I do that? When do I use that?
When you're using a sample, you have a sample.
When I've taken a sample and there's a question or I'm interested in the sample means. If those two things have happened, I have to change my standard deviation. So that's why it's an automatic part of hypothesis testing. That's why it's built into confidence intervals. Both of those, I take a sample, I'm asking about the sample mean. So, of course, that's got to be done somewhere. It's built in, right? What else was in 6? I think that's it. This was 6.2, 6.3. This was 6.4 and 6.5. And then 6.6 was the NAB. Remember that? Oh, yeah. Oh. So when I say use the NAB, what does that mean you're going to have to do eventually?
0.5 up and down.
Yeah, take the number I give you and go up or down by 0.5, because it's really a bar there, right? So if I say probably more than 74 people, put the bar on it. More than, I don't want to include it, so I want to start up here, 74.5, make that into a z-score and go. Right? So the NAB is just one tweak. Central limit theorem is just this one tweak. Everything else is the same except I changed my standard deviation. So if you understand the z-score process, there's 2 whole tweaks that are easy as hell. Change standard deviation or make the number go up and down by 0.5. Right? And then you do everything else is exactly the same as always. That's crazy. Kicks ass. All right. Chapter 7 is where we get this stuff here. Okay. Shoo. That's the formulas from chapter 7. And then chapter 8, the only real new formula from chapter 8 was the one for calculating a z-score for p problem. You remember that? And it actually uses this piece of it. It says, well, this must be, it's the our data, give or take z times the standard deviation. Well, then what the hell is this? That must be the standard deviation. So the hypothesis test for proportion says, well, then that's what the hell I'm going to do. That's what I'm going to use as my standard deviation. It is the standard deviation. Let's see, I'm running out of room here, so. Chapter 8, the only really new formula in Chapter 8 is this guy. And it's not even all that new. Cool? That's how you calculate a z-score from percentages when you're working with percentages. And Chapter 9 is extra credit. If you want to put those formulas on your formula sheet, feel free. Chapter 10, there's no formulas to put down. You really don't want to put it down. Chapter 10 is all process, which you must know how to do. You can't have the process written down. Okay. Ooh. Where is it? There it is. So now we can do whatever you want to do. If you have a suggestion for something else to put on your formula sheet, let me know. I can tell you if it's good or not. Yeah.
What type of material do we need to know that doesn't involve the formulas?
So conceptually, I still hold out hope to have a very high percentage of people get the question, what does the z-score tell you? Correct. Right. I'm hoping. There could be some true or false stuff, like there was about correlation. There could be some questions about, the true or false could be almost anything. You have to understand what a p-value is. You have to understand what the results of a hypothesis test really mean. You have to, what else? Let me think. Understand confidence intervals, how to interpret the results, right? There were some problems in the homework that said, 61% of people said they voted, and then you took and the confidence interval was like 48 to 50 or something. So what would you say about the people that said they voted? What must be true is that some of them must have lied. There's a chance I'm wrong, depending how strong my confidence interval was, what the confidence level was, but what that suggests is that some people lied to me, right? And you can go back to the whole washing hands thing. You can make a confidence interval of, do you wash your hands? And then you can observe, and you can say, well, shit, so he's lying, right? But beyond that, I can't really, it's hard to speak to that because conceptually, you have to understand the concept behind each of these formulas, really, right? Okay. And for example, like these formulas all really came from this one. Remember that? This one is what spawned those guys. If I don't know him, I use X bar. The minute I get an X bar, I've got to change my standard deviation. So if you look at it, that is actually the same formula as that first one up there. Here's the really cool thing. You want to talk about an awesome note. When do I use t-scores? And what's it with? It's with a sample standard deviation. So if you forget that, I really can't feel too bad for you. It's right there. I use a Z when I know this. I use a T when I know that. Bam. End of story. Right?
Well, when we use t-score, we cannot find a p-value. We have to plug in.
You find a range of. So, for example, let's see. You want to look at your t-chart? See if you guys can all find this. So everybody got this here? Okay. So everything I write from here on out cannot be on your formula sheet. One time I made a formula sheet and then somebody asked me a question. I said, I said not on formula sheet, and I did this little problem. And then on the formula sheet was not on formula sheet. The problem. Okay? So now I've got to be a little more specific. If I have, let's say, a sample 101, and I get a T star of, let's say, 1.72. And I want to know what the p-value is for that. First off, what's the degrees of freedom? 100. I like it. 101 minus 1 is 100. Not 1,000, John. So look at 100, and where does my t star fall? In between what two values here? So if you look at 100, where does my t star fall? So, some of you guys are looking at me perplexed. You have to look at the t-chart. At 100 for degrees of freedom, I see 2.626, I see 2.364, I see 1.984, I see 1.66. Oh, cool. So the 1.72 is in between 1.984 and 1.660, right? It's right in between. So look back up. Let's say this is a one-tail test. What two percentages does that lie between then? 1.984, if you look back up, one tail is 0.025. And if you look up on 1.66, 0.05. So I'd say my p-value is in between 0.025 and 0.05. That's where my p-value would be. Because again, the z-score chart is set up beautifully for this, because there's room for it. They have not just this many percentages, they have a ton of percentages, right? Why is this chart harder to set up? Because it would need a chart the size of the z-chart for each of these degrees of freedom. So they said, screw that. Let's just have specific, well-known stuff that happens a lot, percentages up here. But what does that mean for us when I want to be really specific? It means I can't be. Too bad. There had to be a trade-off somewhere. So instead of making this monster of like fold-out map t-score chart, they said, no, just give me an answer of a range. So, for example, if alpha was 0.07, let's go one step beyond. And I know for my t-star, I know that my p-value is somewhere in between those, because my t-star was somewhere in between those. Would I have failed to reject, or would I reject the null?
Reject
What's going to happen for it to reject the null? P-value has got to be less than alpha. Well, my p-value is in between those, and my alpha is 0.07. The biggest my p-value could be is 0.05. So yeah, I would reject the null then, right? So I can still make decisions on a lot of problems, even if I just have a range of values for my p-value. Okay. Maybe. It's obviously not a huge deal. At the most, I'll have one question about a t-score chart p-value, right? Okay. All right. Any other questions about anything?
Can you do some probability problems?
Yes. Cool. What about the ones on the practice test? Might be a little silly because you already have the answers. Do you have anything specific in mind, or?
No, maybe like the ands and ors and givens.
Okay.